Hey y'all. So I have some pretty cool stuff to show today. I made some pretty good improvements on the engine, and I'll be showing those things here in a bit. I usually just kind of start with just showing some code and then get into more of the visuals afterwards. When I was working on some of my new changes, I was cleaning up the HUD so that you can see how much ammo you have, you can see what level you're on, things like that, passwords. And I was using this initially. I was using this draw text string function that's inside a text lib within lib3do, and I read the documentation on it before I used it, and it mentions it's not very efficient. At the time, I was just kind of focused on 100 other things, and so I figured I'd look at this later. And when I started taking this more seriously and kind of benchmarking it and seeing how slow it was, I looked at the code and even talked a little bit about this on Discord. But under the hood, it's using it's creating text cells. So it's basically a cell that has a text rendered in it, and these cells are like other cells. Um, and it creates one every time you call it. It it will draw it, then it will delete it. So every time you call it, so that's not ideal. It also allocates this format buffer, which is something you may not even need. So if you pass in, if you want print formatted style string, this can this is created so that that data can get processed. But like in my case, I don't even need it. So if you look at DrawTextChar, it's really just creating a string and then wrapping around the draw text string. So if you're doing just like a little prototype and you're just trying to get some text on the screen, you don't really care about the performance, um, just for testing purposes or whatever, it's fine. I mean, it's a pretty cool function. But if you're working on an actual project, I would not use it. But it's still cool. Um, so if we want to see an example of just kind of replacing all that, this code here is a good example because it's kind of clean, but it's the logic for clearing a level. It's where I show a password. And you can see, you just create your text cell. You can set the color for a background, foreground. You can update the text. It has a Boolean so that you can control if it's a complete wipe or if it's like concatenating. You set your coordinates. This is fixed point coordinates. And then just like any other cell, you can see how it's linked here. You can control the flags here. You can link whatever you want, change whatever you need. Um, I also got rid of calls to make RGB and just kind of create constants to common colors. So it just saves some more work. And let's see here. There's another way to create text cells. If you look at the code for journals, and we'll be looking at this later more, but yeah, you can create a bunch of arguments and kind of combine some actions in one, really. And I kind of like this better, though. You don't have to deal with the arguments. You may have to call a few more things, but I think this is cleaner for me. Another thing that I did was, if you notice from some previous videos, I had some like fade to black transitions. And the way I was doing that before was I was using this fade to black function that's in lib3do under display utils. And the way it works is you would pass in a screen context, a frame count, and it would go through and update the color lookup table and fade everything out. I copied most of this code, made my own version because, well, for a couple reasons. One is that every time you call this, it's creating a vertical blank IO request, which is something I don't need because I already have one of these. And so it creates it, it deletes it. Um, and also, this is not this doesn't update the actual screen buffer. This is updating the color lookup table, and this is how you get the blackened effect. And so what that means is when the screen completely fades out to black, your last frame that was drawn is actually still there. It hasn't been touched. And so if you were to fade back in or reset the palette, then you'll see the last frame that was there. But in my case, what I wanted to do was I wanted to, well, for one, I don't want to keep calling these creates and deletes, but I wanted to fade out. And then once the screen has faded out, I wanted to actually wipe the screen buffers using the sport bus to black. That way, and then reset the palette. That way, I'm ready to show the buffer or the screen without having to worry about any old artifacts. And I don't want to fade in transition. So after I fade to black, when I show the screen next, I'm just showing the full frame. I'm not doing any kind of fade back in. So for me, it just kind of made sense to copy this and just modify it a little bit. So I did that. Yeah, so here's my fade to black. I remove the calls to the creates, the deletes, and you can see that it this is what actually does the updates. Um, but right here, this is what I added. So it uses Sport to wipe the screen bitmaps, then reset the palette. So even though it restores the lookup table, the screen's already black, so you won't see any artifacts, and the code is just ready for the next frame. Some of these comments are pretty funny. I just kept it. These are my comments, but it feels like this person wasn't sure if this was needed or not, but they included it anyway because the old code did it. And I guess I'm doing the same thing, but it's just interesting to read some of these comments and just see the different styles that people had. It's interesting. It's like a time capsule. Let's see here. So I created a journal system so that I can tell story through the game. And the way that I did that was, and I'll show all the visuals to this in a bit, but um, the way that I did that is I didn't want to, obviously the level editor needs to create this. Nothing is manually created. And I can't load in all journals in a level because that's just too much memory. Depending on how big they are, how many pages they are, how many characters are in there. I mean, it could be pretty big. And so what I'm doing is when you create these journals, the journal data is saved on the disk, and they're numbered in such a way that given the level that you're in and the ID of the journal, this code is able to locate that data, read it in, display it, go through the logic, and then clean it up and release it. So I tested this on the actual hardware, running into a journal, picking it up, and it's not bad. I mean, it takes about a second or so to load up, but I think it's a good trade-off, so I don't have to load more memory than I need. I mean, a player may not even pick up a journal, and so why load the data in? Right? So it's really a linked list of pages. So this is my page struct here with the text it can hold, and then just a pointer to the next node. So it's a linked list, and when the journal start code hits, these start functions can now take in a message to help prepare whatever it needs to do, and so it uses that to identify the journal, and then it will load it in, do its thing. It parses the data out. This is just my little character that signals new page. So if you ever, when you're making the journal, you just can't use that character. Um, I mean, I guess I could do some kind of escape thing, but I don't think that it's really needed. So it creates all the pages, and then when you're during the main loop, it will just wait until you go next page. Once you're done with all the pages, I delete the linked list, free the text cell. So all the journal text is just a big text cell. And what's nice is when you create the cell, you can set it to word wrap, which I think is awesome. Um, Before, when this version, when I wrote it using DrawTextChar, before I realized how slow it was and redid everything, I was like doing all that logic myself to make sure words would fit and it would look good and left the line and all that stuff. And it was just super easy to do with the the lib3do functions. So there's your justify, word wrap. It's pretty cool. But I'll show you this in a bit. And really quick, just to add some context to how all this works, like these, like the start and the tick and the draw and the end, these are all callbacks by the game engine. So it's really all being controlled through this function. So when you call run game loop, you can pass in these function pointers. And I may have talked a little bit about this in the past, but this way, you can kind of branch off. And it does push a new instance on the stack, but as long as you don't go too crazy and you don't nest too many things and you're not abusing memory, it's okay. It's working okay for me. Um, but once it enters, it calls start one time. It will loop until the tick returns false, and then it will call the draw. So tick is more for your non-drawing code and like your logic, and then the draw is more for just drawing, and with some exceptions, I guess. And then end gets called once um, when everything is finished so that you can clean up. So as some examples, you're running through the game, you pause the game. I actually have some states to handle pause, and I update the color lookup table to darken it a bit, and I show pause on the screen, right? And then which you'll see in a bit, and then when you resume, I clean all that up, and then it will pop back to what initiated those handlers, which would be the game state or the play state. And then you run and you pick up a journal. Again, it will call run game loop. It'll call the journal callbacks, and the state that you were at prior is basically frozen, waiting for the code to pop back. And everything starts at the title screen level. So the title screen has its callbacks. So here's like title draw, title end, title tick, title start, and this this will never break out. When you load a game, it calls some load handlers. It's going to end up coming back here anyway and calling this, which is passing in the play states or the play callbacks. This is the main one really, and if you ever go back to the main menu, this is where you're going to end up again. It's never going to break out of here. So it's like, yeah, all the logic starts here and starts to nest, and it's working okay as long as you don't go too crazy and you're conscious of your memory and the stack. Then it should be fine. Famous last words. I also wrote this memory checker that I put in various key points. So, for example, after a level is loaded and wherever there's kind of some major things happening, and what it does is it checks the memory available with against the threshold that I set. And if it dips below that threshold, it warns me. Hasn't happened yet, but as I'm kind of developing, my mind isn't always in like optimization mode. So if I'm doing something on accident that is just bad, this is going to let me know. So this logic will only run when I'm in debug mode. So so I thought that was pretty cool. Um, let's see what else. I added secret rooms. I changed the way the health of the player is represented, a password system. So let's jump into this and start having a look at this stuff. I also switched over to using Cygwin a while back, just to make my life easier, because I am developing on Windows, which is generally fine. I don't have anything against Windows. I just it just makes it easier for me personally. But let me go ahead and launch. All right, so title screen was updated a little bit, but it's not done yet. So these are text cells. That's my version of the fade out there. All right, so I just threw this level together just to help showcase some of the stuff that I was talking about. But so now you can see what level you're on. In this area here, any keys that you pick up, still using old graphics here, will show up here. Your ammo count, your health is this heart rate monitor. So it goes from green to yellow to red to flat line based on your HP. So if I pick up some keys, you can see they're kind of showing up there. All right. There's a journal, which we'll pick up in a second. Um, let's pick up the pistol. And this is a secret room. It doesn't have to look that way in the level editor when you're building your level. You can right click any wall and then just turn it into a secret. Under the hood, I'm using the exact same logic as my doors. So that was a win. But the engine does not push the that wall in like it does a door. So when you look at the doors, they're kind of inset a little bit. I do that in the raycasting code. So when the ray encounters a door slice, it adds half a grid's length to that ray, and then the rest of my math works because it just figures out how small it needs to be and all that stuff. But when it encounters a secret, it doesn't do that last step. So what was nice is I'm able to reuse all the code for doors to make secret rooms. So if I open this up, there you go. Now you got secret rooms. Um, what else is nice is that I made it so when you run out of ammo for a weapon, it'll automatically switch to the next weapon. There you go. And the way this is really working under the hood now is I got rid of the concept of having flags to represent weapons and you have weapon inventory. I simplified the entire thing. If you have pistol rounds, you have a pistol. And if you have shotgun rounds, you have a shotgun. That made it easier when I worked on my password logic because it's less data to store. I wouldn't have to store, okay, you have a pistol, but you have no ammo. It would also be weird, like if you're cycling through your weapons, I wouldn't want you to cycle through a weapon that doesn't have ammo. That to me, that just might be annoying. And was able to get rid of the weapon flags that I had because I don't need that anymore to run this logic. So I thought that worked out pretty well. So here is a journal. So let's pick it up. Yeah, I like this. I think it looks pretty cool. It's got a background, which is easy to change out. And so that's page one of the text. You can see here in my console, how many bytes that data had, um, where it came from. So my schema here so 01 is the level, 01 is the ID of the journal. So if I had one journal in level 2, this would be 0201. And so here, drawing new page journal is just some debugging. That's page 1 basically. Now here I am on page 2 of the journal. I need to add something here to show what page you're on. And then when you're finished with the journal, you can see that it there I have some message here pop up just to help me see that it really did free that up. The loop's working as it should there. So let's go to the next level. Like I said, I just put this together to showcase stuff, so it's not even a level, it's just a room. But here's the password. So the password system that I wrote, it's not like super secure or uncrackable at all. It's actually pretty easy to figure out. I may make it a little harder later, but I'm not too concerned about that really. But it encodes like the level that you're going to, and uh, if you had pistol rounds, how many, shotgun rounds, how many, and the health that you had. So as you go level to level now, I maintain state. Um, the engine knows what you started with when you entered that level, and that's what gets encoded and decoded. I'll show you that in a second. When you enter a new level, I maintain the health that you had prior, and rather than refresh the health. I think I'm going to try that. I think that that's probably okay. It may make it a little more challenging, but I think as long as the levels are designed right, it won't be ridiculously hard. Um, but if we, and this is just temporary, I just need a screen to show the password, but I'm going to clean up what that looks like more later. But you can see here now we're at level 2. Obviously, we have no keys. That always gets reset. Levels may not even have keys. And yeah, our health there, we only have a pistol. And what I'll do is, let me save this real quick so I just don't forget it, because we're going to be using that in a bit. Uh, okay. And let's have our character die. So there's a baddie hiding behind this pillar. Yeah, I like that. So let's exit out of here and let's load. Let's try loading the game in. All right, so this time we're going to go to load game and we're going to go OO. LG. LLL. Z. There it goes. It worked. It's fading out. Yeah, now I started off level 2, 7 rounds. All right, so what I'm going to do now is work a little bit on the raycasting optimization. I think it's okay right now. I mean, the frame rate I think is decent. It runs. I mean, with all said and done, with the entire engine, the entire level, everything, it's running between 16 to 21 frames per second. As long as you don't have a room that's super large, because the larger room that you have, the farther the rays have to travel, and then um, there's an inner loop within the raycasting process. I think that's taking up some time. But if we go to the raycasting code, this is really the meat of everything. It was the first thing that I wrote, and I had to first write this within like this 2D grid system. So with the lines of the grids, so I can see exactly when the rays are intersecting and make sure everything was working right. I'm going to go through and add some lookup tables to this stuff. I had started doing that. This was some lookup table code that I had, but what was interesting is the lookup table was actually taking the same amount of time, but maybe I was making a mistake there. But so I'm going to go back to looking at that. But basically the way this works is if we have a grid, and this is really the heart of the engine. And we're casting out array, looking for intersections with walls. Let's say the player is here and the ray is coming out like that. Let's just say it's coming out like that. So there's different intersections that are occurring here. So let's just put a P here for the player. I'm not good at this, but um, so there's an intersection point here. There's an intersection point here. There's one here. There's one here. And there's one here. And so you're probably thinking, well, why do you need um, so many intersection points? Well, because it depends. Some of the walls are going to be running along this y plane right here, right? And then some of the walls are going to be running along the x plane, like this one. And so what happens is I'm really casting out two rays, not one. One ray is geared towards looking for intersections against walls on the x plane, while another ray is geared towards looking for intersections along the y plane. And when these rays finish, the ray that is closest is the ray that is used for that ray's corresponding um, sliver on the screen, because the entire screen is drawn in slivers. So this ray might be drawing this sliver, for example, and the sliver is centered, and then the height of that slice is based on the distance. So with some correction for, like, fish, what they call fisheye distortion. That's basically the algorithm to cast out a ray and then calculate the distance, and then do your do your perspective drawing from there. So these are all this ray is basically a bunch of right triangles. That's a horrible color for this. Um, so like this would be the very first intersection point for the y ray, and then this would be your step size for the y ray, and then you keep adding this and this to your ray until it hits something. So you only really need to do the math a little bit to get to that first intersection, and then to get from there to calculate what your step's going to be, and then you're just reusing this again and again and again. So this is just using some trigonometry, but in my implementation here, I used the point slope formula and just kind of did a little algebra to figure out the intersection points. And I think by doing this, I cut down a little bit, like on some cosine or sine calls. Um, I'm already doing like shifting where I can. I probably could have got away with doing some shifting here, but because the width is dynamic, um, I'm not doing that. I mean, there's tricks you could do too, where you can figure out, like, separate your shifts and then add them together, but like sometimes that just ends up becoming just as slow as just doing the multiplication. Um, but there's stuff that I can do here. I want to look more at the inner loop, start there, and see what I can do um, without having to do any assembly. We'll see, but we'll see. Anyway, I'm rambling. I hope you enjoyed this. Thank you for watching, and if you have any questions, let me know. And you know what? I think I just almost forgot to show you my pause. It's not fancy. It's not that exciting, but I am getting forgetful. I like it because I'm keeping the frame, the last frame that was drawn. I'm updating the color lookup tables to darken everything just a little bit, and then yeah, this is now going off into its own um, handlers, its own start, tick, draw, end, and restore the palette. So everything is paused basically. Once you pop back, you have everything where you left it. So all right, well, thanks again, and hope you enjoyed.